Hello grade 11s. Today we're going to talk about the electrical system of the heart. So we talked last class about the actual mechanics of the heart, right? We talked about the pressure differences that occur in your heart chambers and how blood flows as a result. But what is it that actually causes that muscular contraction in the first place? Well, it all starts with something called your sinoatrial node. Now, sinoatrial, it's found on your right atria, hence the atrial. And this is also called the pacemaker. This initiates your heartbeat. So, how does this actually initiate your heartbeat? Well, an electrical impulse from the brain is received by the SA node. Now, your brain does control, obviously, how fast your heart beats, right? If you're doing vigorous physical activity, well, you're going to need more oxygen getting to your muscles, more oxygen getting to the cells of your body, and you're going to have to get rid of more carbon dioxide waste, so your heart rate will increase. If you are resting and relaxing or sleeping is where your heart rate gets the lowest, well, then obviously you don't have those same stressors and you don't need to have as high of a heart rate. Interestingly, however, your SA node will continue to fire at a basal rate if it's disconnected from your brain. So if I reached into your chest and ripped your heart out, it would continue to beat in my hand, which is kind of interesting. Now, once your SA node gets the signal from the brain, it fires, and the impulse spreads quickly over both atria, causing the muscles to contract. So that signal causes your atria to contract from the top down, right? Because that SA node's kind of at the top of your right atrium, so that signal causes both to rapidly contract from the top down. Now, once that electrical signal gets to the AV node, the atrioventricular node, that signal will be transmitted. So the impulse is transmitted by the AV node down a nerve bundle called the bundle of His. And this bundle of His lays in the septum of your heart. So the barrier between your left and right sides of your heart, your left and right ventricle, there is a bundle of nerve fibers that goes all the way down to the bottom of your heart. Now, why would you want that? Why wouldn't you just want the signal to go straight from your atria to your ventricles? Remember, your atria contract from the top down, but where are the arteries on your heart? All right, let's go back to that picture for a second. Where are the arteries on your heart? Well, your arteries are coming off the top of your heart. So once that electrical signal gets to the AV node, we transmit that signal to the bottom of the heart, right? To the bottom of the heart here, such that your ventricles can contract from the bottom up. Right? We want our atria to contract from the top down, and then our ventricles from the bottom up, because we're pushing blood up into those arteries. Right? So your heartbeat's going to be down, up, down, up. So here is the AV node. This is the bundle of His. And then the bundle of His branches to your right and left ventricles, and that signal is transmitted over your ventricle, and you contract from the bottom up. Interestingly, your pacemaker controls your heartbeat for the entirety of your life. If it fails, you need an artificial pacemaker. Now, if it fails and you don't get medical attention in time, obviously you will die. So what happens if the pacemaker goes out? Well, you will die because your heart will stop beating. Now, they will not be receiving the electrical impulses they need in order to contract. Your heart will completely stop beating. And in these situations, you will die very quickly. But you can get an artificial pacemaker, one that will keep sinus rhythm for you. In fact, nowadays they are super, super fancy. My grandfather had a massive heart attack, and part of that As he actually got an artificial pacemaker slash defibrillator combo put in his chest, and it's really, really fancy. When he goes to the doctor can scan it, and it goes up on the doctor's computer, and it's a record almost of my grandfather's heart activity. And he can be, he can say like, "Hey Roy, what were you doing on April 10th?" And Roy will be like, "Oh, I was shoveling the walk." And his doctor will be like, "Well, Roy, you can't do that anymore. Your heart rate got too high." So the technology is getting quite impressive. But these artificial pacemakers, they do take over the role of your pacemaker on your heart, and they start that contraction by literally giving your heart a little shock. Now, what part of your brain actually controls your heart rate? Well, you have two nerves, both innervated by the medulla oblongata. You have the cardio accelerator nerve, which you can probably guess what that does. It's going to speed up your heart rate. And you have the vagus nerve, which slows your heart rate down. So here for the medulla, we have the vagus nerve and the cardio accelerator. Now, remember, we talked a little bit about this in digestion. We'll mention it again in the nervous system. But your sympathetic nervous system, that is your fight and flight. Right? If you're being chased by a lion, obviously your body is going to get prepared to run really fast. Your heart rate's going to increase. But if you're, chilling on the couch, eating a slice of pizza, well, your parasympathetic nervous system will kick in. That is your rest and digest system. Now, the medulla is the thing that's going to control your heart rate by sending messages via those nerves to your SA node. And remember, your SA node sends that to your AV node, right? Once that electrical signal gets to that atrioventricular node, it's going to pass down the bundle of His down to the bottom of your ventricles to cause your ventricles to contract. Now, blood pressure. Blood pressure is a good thing to measure for doctors because it can give some indications of health issues. Where do you think blood pressure is the highest in your body? Think about it for a second. Where is blood pressure the highest? It's going to be the highest in your aorta right off of your left ventricle, right? Your left ventricle is a super thick wall of muscle, great force of contraction. It's going to cause a lot of blood pressure in that aorta. And as the blood spreads out throughout your body, the blood pressure goes down and down and down until you get into your veins where the blood pressure is the lowest. Now, you may have seen how we measure blood pressure. And blood pressure is measured, by the pressure that your blood exerts on the walls of your blood vessels, but we use a device to measure this. It is the sphygmomanometer. They probably could have came up with a better name. Now, this blood pressure cuff will measure the amount of pressure your arteries are putting against this cuff, right? It inflates, it cuts off that blood circulation, then it slowly releases the pressure until blood starts flowing. And based on that, it can measure what your blood pressure is. Now, it measures the highest point in pressure and the lowest point in pressure. So it measures the pressure when that wave of contraction from your heart gets to the cuff, and then it measures the pressure right before your heart beats again, right? Because that's where pressure is going to be the lowest in your system, is right before those ventricles contract again, your blood pressure is the lowest it's going to be. So the high pressure we call systolic, and the low pressure we call diastolic. Remember, systolic where your heart's contracting, diastolic when it's relaxing. So it's the pressure where it is the highest point when that blood pump from your heart gets to the cuff, right? That pressure wave. And then the lowest point right before your ventricles contract again. So A normal pressure would be 120/80. That means that their blood pressure, their high end would be 120 millimeters mercury, and their low end 80. So that would be considered normal. Now, high is 140/90. Anything around that range or higher would be considered high blood pressure. Now, high blood pressure does increase your chances of stroke or heart attack. So if you do have high blood pressure, it is something that you do want to take care of by doing things like reducing salt intake, for example, getting your weight under control, ensuring you are of good cardiovascular health, right? Getting a lot of exercise. These are ways you can reduce your blood pressure. So now let's talk about the divisions of circulation. So what are the two loops in our body, and what are the main loops found within the body that supply things like our kidneys or our liver? So obviously the two main loops are going to be from your heart to your lungs and back to your heart, and from your heart to your body and back to your heart. So the pulmonary loop, pulmonary circulation from your heart to your lungs and back, and then the systemic loop from your heart to the entire body and then back to your heart. So your pulmonary circuit, what is the whole point of it? Well, we need to oxygenate our blood and get rid of the CO2. So the deoxygenated blood from your body will be pumped via the pulmonary artery to your lungs, where it can be oxygenated, right, in those alveoli. And then that oxygenated blood returns back to the heart via the pulmonary vein, where it can then be pumped to your body. And then we have the systemic loop, where the oxygenated blood from your left ventricle is pumped into your aorta, and then that blood will go to the entirety of your body. And then once that blood has dropped off its oxygen payload and picked up that CO2 waste, it will return to your heart via the inferior superior vena cava. Again, important thing to note is that your heart does have arteries and veins. Obviously, we do need to supply our heart with blood because it's a muscle, right? It needs oxygen to do cellular respiration to burn that sugar. So the coronary circulation is extremely important. And when we talk about heart attacks, a lot of people have these misconceptions about heart attacks. They think a heart attack is, your heart just stops randomly. Heart attacks are going to be a blockage within one of your coronary arteries. So when there's a blockage in one of these arteries, a complete blockage, maybe there's a fatty plaque that broke off and is now clogging that artery, what do you think is going to happen to the muscle, to the heart tissue that artery feeds? Well, it's going to be starved of oxygen, right? So starved of oxygen, it will die. So a part of your heart begins to die. So coronary circulation is very important. And keep in mind, heart disease is one of the leading causes of death in North America, and it's on the rise. So ensuring you have healthy arteries is essential to your longevity. Another important part of the circulatory system is the hepatic portal circulation. We talked about this in the digestive system, right? All of that blood from your small intestines carrying those nutrients, those things absorbed in your small intestine, are going to pass through your liver via the hepatic portal vein, right? Why do we want to do that? Right? Remember, our liver has like over 500 functions, and a lot of that is metabolizing and modifying those things that you absorb into your body. So again, that is an extremely important circulatory system loop. Another really important one we're going to talk about in the excretory system is the renal circulation. So when your blood flows into your kidneys, this will filter out some of the things in your blood, and your kidneys will treat that filtrate and help remove some of those waste products from your blood and from your body, aka urination, right? You're gonna pee some of that stuff out. So renal circulation is very, very important. When we get to the excretory system, we're going to talk quite a bit about the blood pressure in your renal artery and how that affects the amount of filtrate you are producing. Now, again, it sucks that we're not able to do the heart dissection, but there is some important things I do want you to take note of when it comes to the heart anatomy. A lot of this stuff here, I don't really expect you to know, but some important things, obviously you do need to know the arteries and the veins that come to the heart and leave the heart. You have to know the heart chambers. You have to know the valves of the heart. And you are going to have to understand the septum, the electrical system of the heart, and understand heart disease. In fact, we're going to do an assignment on that. I'm going to be posting that today on heart disease and the importance of having good and healthy arteries that supply blood to your heart. So, there were a couple things I would point out if we are doing the heart dissection, how to tell the front from the back. For example, when we are trying to determine that, we're going to look here for the anterior interventricular artery, the one that runs right here, right down the middle of the heart, down the septum, because that can tell us what's the front versus the back. So again, here are the important things that you do need to know. So you need to know the valves, the chambers of the heart, and the arteries and veins that come off of your heart. So again, the coronary artery supplies blood to your heart, gives it that life-sustaining oxygen it needs. And the coronary sulcus encircles the heart like a crown. Coronary corona's crown. The atria are found above the atria are found above, and the ventricles are found below this blood vessel. So it does separate here. You can see it. It does separate your atria from your ventricles. And again, if we did dissection, lots of students are always shocked. They're like, what? These are our atria? Because they're like these little sad, pitiful sacs, because the muscle's very, very thin. But when we cut into the ventricles, the ventricle walls are super thick. The volume is, equivalent, but they have these very thick muscular walls. So what happens when there's a blockage within the coronary artery? We already mentioned this. This is a heart attack, right? So when someone has a heart attack, when there's a complete blockage of their coronary artery, it cuts off blood flow to a part of their heart, and their heart literally does begin to die of oxygen deprivation. And unfortunately, this is a case of what kills you definitely does not make you stronger. So when you have a heart attack, your heart muscle begins to die. If you survive the heart attack and you fully recover, your heart will never be the same. That heart muscle degrades over time, and it becomes calcified and hardened. So you actually lose a lot of efficiency in your heart, and your heart will just never function as well ever again. So you do need to take care of your heart and its arteries. That's the apex. Now the apex, again, points to the left, right? And that's why you have that smaller left lung versus right lung. And again, the apex is another important term for determining orientation of the heart. I talked about the function of the pericardium, right? It protects the heart, it anchors it, it provides a lubricated space where it can function in an effectively a friction-free environment. But how does it protect the heart, you might ask? There's a good analogy for this. It's kind of like if you were to shove your fist into a balloon, right? You have that almost barrier that protects it. That's kind of a good analog for how the pericardium actually protects your heart. So your myocardium, again, is your heart muscle, very specialized muscle, tons of mitochondria, very efficient. And there are some other layers of your heart I didn't really talk about. They're not going to be too relevant, like your endocardium and your epicardium, for example. But let's talk briefly about those two big questions I asked. This goes back to the last lesson. So, why do you think there is a thicker layer of myocardium, of heart muscle, in the ventricles compared to the atria? Why is that? Where do your atria have to pump blood to? They're only pumping blood to the ventricles, right? And they're assisted in that pumping due to the massive low pressure in your ventricles after a contraction, right? So they don't really need to be very thick at all. Whereas your ventricles, they're pumping blood to your entire body, right? To your lungs and your whole body. Another big question. Why is it that the left ventricle has much thicker muscle than your right ventricle? Think about it. Where does the right ventricle pump blood to? Well, just to your lungs, right? Whereas the left ventricle is going to pump blood through your aorta and to your entire body. So the walls of your left ventricle are the thickest in your heart. Okay, so we talked about the electrical system today of the heart. Understand what it is that causes your heart to contract, so that sinoatrial node, and once that electrical signal gets to the AV node, it's going to cause your ventricles to contract. And remember, it's top down, bottom up. And also understand the different loops of circulation. Now, again, we've talked about hepatic portal circulation already. We are going to spend a lot of time talking about renal circulation in the excretory system. Right on. Have a good day.